Welcome to this class. Today we are continuing simple machine, and this is the chapter of class 9 Science and Technology Unit 8, and this is part 2. In part 1 you are taught about mechanical advantage, velocity ratio and efficiency in detail. And what is simple machine was also done in previous class. Simple machine, mechanical advantage, velocity ratio, etc. were done in previous class, and types of simple machine was also told in previous class in part 1. Now I am starting part 2. In part 2 we are going to focus on pulley system. But before the pulley system, I want to recall some of the matter which are very essential to understand pulley from first class, I mean to say part 1. Now, what is simple machine? First we have to remember this. What is simple machine? Simple machines are the tool or device which makes our work easier, faster and convenient. Look at these words: easier, faster and convenient. I want to tell you the meaning of this words also. Simple machine makes our work easier. How? This is a lever and we are trying to turn a heavy stone with the help of this lever. And let's say heavy stone is very heavy, it is 1000 Newton, and by applying just 100 Newton, if we are able to turn it, then what happened? Then less amount of effort is applied to turn heavy stone. It means it makes our work easier by reducing the required amount of force. I mean to say, this machine magnified the force. 100 Newton is magnified to 1000 Newton. Why? How? It is possible only when effort distance, that is the distance from effort to the fulcrum, is if greater than the load distance, that is the distance from fulcrum to the load. If effort distance is greater in a simple machine, then we can raise a heavy load by the application of less effort, and thus a simple machine makes our work easier. This is the meaning of simple machine makes our work easier. Now next, simple machine makes our work faster also, easier and faster. What it mean? Look at this, is a lever and we are trying to raise a load, and if we apply force this way, then lever turns like this and load is raised to this much height. Load is raised to lot of height. When effort covers very less distance here, this is effort distance. At the same time, load covers very huge distance here. Look at this. When effort covers less distance, let's say we pressed it to this much distance in 1 second, within the same 1 second the load rises to this much huge distance. What it mean? It means work becomes faster. Yeah, if effort distance is less in the simple machine and load distance is high, then the simple machine makes our work faster. This is the meaning of how the simple machine makes our work faster. Now let's say another point also, how simple machine makes our work convenient. I want to show a small video clip. In this video clip, a man is using pulley to raise a heavy load. Without the pulley, if he want to raise this heavy load, then direction of force will be vertically upward. But using this pulley, he is pulling the rope in the downward direction. It means without the machine, he had to apply force in the vertically upward direction, but using the machine, the direction of force is changed to a convenient direction because of this pulley. That's why sometimes the simple machine changes the direction of force, and that makes our work convenient. So we can conclude that simple machine are the tool or device which makes our work easier by magnifying the effort, which makes our work faster when effort covers short distance and load covers very huge distance, then work becomes faster, and it makes our work convenient if it changes the direction of force towards convenient direction. Okay, now after this, you are told in previous class also there are major 4 types of simple machine. I want to name them again. What are they? Lever, pulley, wheel and axle, and inclined plane. These are 4 types of simple machine. But inclined plane is sometimes modified to form another machine, and they are called screw and weighs. Actually, somewhere may be written there are 6 types of simple machine, but this screw and weighs comes under the inclined plane because they are modified version of inclined plane. Okay, after the recall of this, now I want to enter into pulley. Now exactly what is pulley? Have you seen pulley? Where it is used? What is pulley? I want to show you one diagram. Look at this, one picture. In this picture, pulley is suspended somewhere. This is the front part of the crane. Actually, from the crane it is suspended and it is used to raise heavy load. See this also. Wow, many pulleys are used together in this crane and all of them are actually used to raise heavy loads. We can conclude that pulley is used in the crane to raise heavy load. This is one of the great use of pulley. Now look at this another picture also. Here again pulley is used. This is a well and a pulley is used to pull water from the well. And a rope passes through a sieve. One end of the rope is connected to the bucket. Another end is kept free for the application of effort, and we pull water from the well by using this pulley. That's why we can say that pulley is used to pull water from well. This is another very important use of pulley. Now look at this another. This is flagpole, and at the top of the flagpole a pulley is attached with the flagpole and a rope passes through the sieve of this pulley, and if flag is tied with one of the part of the rope and another part of the rope is pulled down, flag rises up. This can be seen this way also. Look at this is exactly the pulley which we attach at the top of the flagpole. This is the pulley and this is the screw, or we can use here nail or screw to attach this pulley at the top of the flagpole. That's why we can say that pulley is used in flagpole to raise the flag. Okay, I told you some example of pulley. Pulley is used in crane, pulley is used in well to pull water, pulley is used in the flagpole to raise the flag, etc., etc. But exactly what is pulley? How can we define pulley? What to say about pulley? I want to define pulley. Look at this. Pulley is a groped wheel or the combination of groped wheel in which a rope or a string is used to raise a heavy load. Groped wheel means this is a wheel, but at the rim there is sieve in which the rope can be fitted. I mean to say rope can move from the sieve. And pulley is a groped wheel or the combination of groped wheel. It means a pulley system may have only one pulley, or maybe 2 pulleys can be used in the pulley system, or 3 pulleys, 4 pulleys, maybe 1 or more wheel. And actually all the wheels are groped in which a rope or string is necessary part of the pulley. Without the rope or without the string, pulley does not exist. Okay, now whatever is the pulley, one single pulley or 2 pulley, 3 pulleys or 4 pulleys, but all the pulleys can be categorized broadly into 2 types. They are fixed pulley and movable pulley. That's why I want to tell you about fixed pulley. What it means? Look at this is fixed pulley. A pulley connected to a rigid support and a rope passes through a sieve. One end of the rope is connected to a load and another end is kept free for the application of effort. This is fixed pulley, and we can define this way. A pulley connected to a rigid support which does not move up or down with the load is called fixed pulley. Okay, in the same way, another type is movable pulley. Look at this. This pulley is connected to the load and it can move up and down with the load. But the rope, one end of the rope is connected to rigid support and this rope passes through the sieve of this pulley and another end is kept free for the application of effort. When we apply effort at this end, then pulley moves up along with the load. It carries load along with it. It means this is movable pulley. We can define this way. A pulley connected to a load and moves up or down with the load is called movable pulley. Now, looking at the pulley system, you can recognize which one is movable, which one is fixed. I want to show some of the pulleys. Look at this. This is fixed pulley, which is connected to a rigid support. This is movable pulley, which is connected to the load. And here we have two pulleys. One is connected to the rigid support, another is connected to the load. This is fixed pulley, this is movable pulley, this is combined pulley. Fixed and movable is combined with each other. This is also called compound pulley. Here we have three pulley system, but two pulleys are mounted in a block, which is connected to a rigid support and it doesn't move up and down. But this pulley moves up and down. When we pull this rope, then these two pulley rotate around its own axis, but they do not move up and down. But this pulley moves up and it carries weight in the upward direction. This way, this is the combination of movable and fixed pulley. This is also the combination of fixed and movable, but this is single and movable. This is single and fixed. Now, how can we divide pulley into different types? There is certain method. Now, I am talking about the types of pulley. Look at this. There are basically four types of pulley: single fixed pulley, single movable pulley, compound pulley. These three are given in your book, but there is another type also, which is called block and tackle. I want to show all these here in the real appearance. Look at this. This is single fixed pulley. Look at this. Only one pulley is connected to a rigid support, and if I pull this rope downward, actually we are using thread. This is the model of pulley. Really, this is not the pulley. Pulley which is used in crane is pulley. Pulley which is used in flagpole or well is the pulley. These are the models of pulley which we use in laboratory. This is single fixed pulley. Only one pulley is connected to a rigid support and load is tied at one end of the rope and we apply force at another end. This is single fixed pulley. Okay. Now, single movable pulley. Can you recognize among these which one is single movable pulley? This one is single movable pulley. When we pull this end upward, then the load can be raised upward like this. This is single movable pulley which moves up and down with this load like this. Now another is combined pulley. I told you combined pulley. Actually it is called compound pulley. This is single fixed pulley and this is single movable pulley. When single fixed and single movable pulley are combined, then we will get this compound pulley which has two pulleys. Okay, now this is the last one, block and tackle. Block and tackle consists of two pulley blocks. One is connected to a rigid support which doesn't move up and down, and another block is connected to the load which moves up and down along with the load like this. It moves up and down along with the load like this. And this is the block and tackle. And this is this compound pulley. One of the pulley is moving, another is not moving. And in this case, the pulley doesn't move. I mean to say, it doesn't move along with the load. It just keeps on rotating around its own axis. And in this case, the pulley moves along with the load up and down. Now I want to define all these again. Now, let's go to the definition. Single fixed pulley. How can we define this single fixed pulley? Look at this pulley. Single fixed pulley consists of a pulley connected to a rigid support. A rope passes through its sheath and one end of it is connected to the load, another end is kept free for the application of effort. This is single fixed pulley. Now, how can we define this way? A pulley connected to a rigid support in which a rope passes through its sheath and one end of the rope is connected to the load and effort is applied at the another end is called single fixed pulley. If you are told to define single fixed pulley, you can define this way. Or if you are told what is single fixed pulley, you can write like this. or you can say like this. Now, single movable pulley, second type of pulley. Look at this is single movable, and rope is connected to a rigid support which passes through the sieve of movable pulley, and load is connected to the movable pulley. We can define this way: a pulley connected to a load in which a rope passes through a sieve, and one end of the rope is connected to the rigid support and effort is applied at the another end is called single movable pulley. Now, what is compound pulley? This compound pulley is very easy. We can remember very easily. It is a combination of fixed and movable pulley. A pulley made by the combination of a single fixed and single movable pulley is called compound pulley. I want to show you a small video clip, short video clip, to make you clear that how single movable and single fixed pulley is combined in making compound pulley. Look at this. This video clip says that this is single movable, this is single fixed, and when they are combined, then we'll get compound pulley. You can see this again. Look at this again. If this single movable and single fixed is combined, we'll get compound pulley. But we usually make this type of diagram or this type of diagram. Both of them are same. Only the position of this fixed pulley is a little away. If it is placed just above this movable pulley, then we'll get this diagram. Okay, this is compound pulley. Now let's talk about block and tackle. Look at the screen. Block and tackle consists of two blocks of pulley. One block is connected to a rigid support, another is connected to the load. And we can define this way also: a system of pulley made by the combination of two blocks of pulleys. One is movable and another is fixed, and at least one block contains two pulleys is called block and tackle. It means we have two blocks and at least one of the blocks should contain two pulley, otherwise block and tackle doesn't form. Block and tackle might have 4 pulleys or 5 pulleys or 6 pulleys or 8 pulleys also. It depends upon how many pulleys are connected, but there must be 2 blocks. Okay. Now I want to show you the model of pulley which we use in laboratory. Look at this is one of the model, and here I am showing different pulleys in single fixed, single movable also. This is the model of pulley, and model of pulley may be like this also. Look at this, 3 pulleys are tied together. This is also interesting type, isn't it? Pulley is of different types. These are the models which we use in the laboratory. Okay, now I want to talk about mechanical advantage, velocity ratio and efficiency of pulley system. What is mechanical advantage? Actually, the mechanical advantage of pulley system is same as the mechanical advantage of other simple machine. The same definition. We can say the ratio of load to the effort is called mechanical advantage, and its equation is, or its formula is, MA equal to load by effort. It is same for every simple machine, and that's why if load is given and effort is given, dividing load by effort will get mechanical advantage. If mechanical advantage is 2, it means the applied effort magnifies by 2 times. If it is 3, then we will be able to raise a 3 times heavy load by less effort. I mean to say, if 100 Newton is applied, then 300 Newton load can be raised. This is the meaning of mechanical advantage, and this is same for every simple machine, and it was taught in previous class also. Okay, let's talk about efficiency of pulley system. This is also same as other simple machine. What is efficiency? The ratio of mechanical advantage to the velocity ratio expressed in percentage is called efficiency. And for pulley also the same, and for lever also, and wheel and axle also. To every simple machine this definition is same, and its formula is eta. Efficiency is denoted by eta equal to MA by VR into 100%. It was told in previous class also. But efficiency has another definition also: the ratio of work output to the work input expressed in percentage is called efficiency. And its formula is eta equal to work output upon work input into 100%. This part was taught in previous class, that's why I don't want to explain a lot. But there is a twist in velocity ratio of pulley system. Velocity ratio, normally we say that the ratio of effort distance to the load distance is called velocity ratio. This is true for every simple machine, including this pulley system also. VR equal to effort distance by load distance. But in different simple machine, effort distance and load distance appears differently. That's why velocity ratio in case of pulley system is defined this way. The number of pulleys or the number of segments of the string or rope supporting the load is the velocity ratio of the pulley system, and its formula is VR equal to number of pulley or number of segments of the string supporting the load. Looking at these words only, we cannot understand clearly. I want to show some diagram and I'll tell you the velocity ratio of different pulley system. Look at this diagram. Here, one segment, this segment of the pulley. Here, this segment of the rope is supporting the load. This segment is not supporting the load because it is coming from fixed pulley. That's why number of segments of the rope supporting the load is only 1. That's why velocity ratio of this pulley system is 1. Velocity ratio of single fixed pulley is 1. The second one is single movable pulley. How many segments of the rope is supporting the load? This and this. These two segments of the rope is supporting the load. And these two segments are supporting the movable pulley, and movable pulley is supporting the load. That's why number of segments of the string or rope supporting the load is 2, so its velocity ratio is 2. What about this third, this compound pulley? Here also 2 segments of the rope is supporting the load. That's why its velocity ratio is also 2. This segment is not supporting the load because this segment is not coming from the movable pulley, not supporting the load. It is coming from fixed pulley. So number of segments of the string supporting the load is 2. That's why velocity ratio of this combined pulley is, or compound pulley is also 2. But what about this? Here we have 4 segments, 1, 2, 3, 4. 4 segments of the rope are supporting this movable block, and movable block is supporting the load. And so number of segments of the string or rope supporting the load is 4. So its velocity ratio is 4. This way we can conclude the velocity ratio of different pulley system. But by the way, look at another point also. Here number of pulley is 1, VR is 1. Here number of pulley is 2, VR is 2. Here number of pulley is 4, VR is 4. It means number of pulley also represents velocity ratio. And this case is exception. How exception? Here we have only one pulley, but its VR is 2. What it mean? It means number of segments of the string supporting the load is genuine definition of velocity ratio, but number of pulleys used in the pulley system is velocity ratio. This is not so correct for some of the pulley system. So we have to be careful that just counting the number of pulley all the time, we cannot correctly decide the velocity ratio of particular pulley system. But certainly counting the number of segments of the string or rope supporting the load, we can declare the velocity ratio of particular pulley system. Okay, I told you a lot about all these. Now, do you know that if velocity ratio is 1, what it means? Velocity ratio 1 means velocity ratio equal to effort distance by load distance. Effort distance and load distance are if equal, then VR becomes 1. Velocity ratio 2 means what? If effort distance by load distance is equal to 2, it means effort distance is 2 times greater than the load distance, then we will get velocity ratio 2. And velocity ratio 4 means if effort covers 4 times more distance than that of the load, then its velocity ratio will be 4. This I think you remember. I explained a lot about the pulley system. What is pulley and different types of pulley, where it is used, etc., etc. Now after this much explanation, I think it will be better to have a question, and with the help of question I want to refresh you. Okay, let's see this question. A statement is given, all the pulley system can magnify the force if the friction is neglected. Is this correct? Just evaluate it. Now next, argument 1 over it is load distance never be longer than effort distance in the pulley system. Is this correct? Now next, argument 2, velocity ratio of pulley system is equal to the number of pulleys of the pulley system is not correct for all the pulley system. These are the statement and argument. Now I think you are watching it very carefully. I mean to say you are evaluating each of them very carefully. Now we have to select one of the option among these. Only the statement is correct, statement and argument 1 is correct, only the argument 1 is correct, both the argument and both the arguments are correct, but the statement is incorrect. Okay, let's check it out. Number 1, option number 1, only the statement is correct. Now is it correct? All the pulley system can magnify the force if the friction is neglected. No, single fixed pulley cannot magnify the force. For the magnification of force, effort distance should be longer than the load distance, but in single fixed pulley, effort distance and load distance are equal. VR is 1. That's why it cannot magnify the effort, magnify the force. That's why this statement is not correct. Option 1 we have to drop. Now number 2, statement and argument 1 is correct. Statement is if incorrect, then why should we go through argument? This is not correct. That's why I'll drop this 2 also. Now 3, only the argument 1 is correct. Let's go through argument 1. Load distance never be longer than effort distance in the pulley system. What do you think? Is this correct? Yes. Load distance never be longer than effort distance. In single fixed pulley, load distance is equal to effort distance. In other pulleys, effort distance is longer than load distance. That's why load distance never be longer than effort distance. Number 3 seems to be correct, but only argument 1 is correct is told here. What about argument 2? We have to go through this option number 4 also. Both the argument are correct, but the statement is incorrect. Statement is incorrect, it is already decided. And argument 1 is correct, decided. But both arguments are correct. Let's go through second argument. VR of pulley system is equal to the number of pulleys of the pulley system is not correct for all the pulley system. Yes, this I told you previously that in some cases we cannot decide the velocity ratio looking at the number of pulley. Just for example, single movable pulley, its velocity ratio is 2, but number of pulley is 1. So the argument 2 is also correct. That's why among these 4 options, fourth one will tick. Okay. Now I told you about this also. Now I want to go through numerical problem also. We know MA VR efficiency. It was done in part 1. Now with the help of those equation formula, I want to solve some numerical problem related to pulley system. Look at the problem. Calculate the mechanical advantage of the 4-wheel pulley system. If its efficiency is 90%, what amount of load can be raised by this pulley system if 500 Newton effort is applied on it? Sometimes what happens, looking at the numerical problem, we feel that this is very difficult. But no, if we write the information of the given numerical problem in mathematical form, then we can feel it very easy. Okay, let's write the information on the board and we'll solve it. Calculate the mechanical advantage of a four-wheel pulley. Means what? Velocity ratio for four-wheel pulley is 4. We can take velocity ratio 4. Now next is four-wheel pulley system is efficiency is 90%. Efficiency means eta. It is symbolized by eta. It is 90%. Okay. Now for the information, what amount of load can be raised by this pulley system if 500 Newton effort is applied? 500 Newton effort is applied means effort is given and this is 500 Newton. And what is the question? What amount of what amount of load can be raised? That's why load is equal to question mark. Okay, this is the information of the numerical problem. Now I want to solve this. We can solve this way. Eta, efficiency, is equal to mechanical advantage upon velocity ratio into 100%. We know this. Now this is equal to eta given 90% and mechanical advantage is load by effort. That's why I'm writing load by effort, and divided by velocity ratio is 4 into 100%. Now percentage cancel each other and 0 cancel, and in left hand side we will have 9. This is equal to load is the question. That's why I am writing load is the question. That's why load is written L, and effort is given 500 Newton. 500 Newton, and this 4 also goes in denominator into 4 into 10. Now if we multiply this 500 with 4, 9 is equal to load by 500 multiplied by 4 becomes 2000, and this is Newton into 10. 0 cancel. Now if 200 is taken to left hand side, then we will have load equal to 200 into 9. That means load is equal to 1800 Newton. This is our final answer. It is very easy. We can solve this numerical problem easily. Now I want to show you another numerical problem also. Look at this. If 300 Newton effort is used to raise a load of 750 Newton by the given pulley system, calculate the efficiency and work output when effort is applied to 3 meter distance. Now I am writing the information given in this numerical problem and we will solve it easily. Effort is given. Here effort is given. Effort is 300 Newton, and another what load is given, L is equal to how much? 750 Newton. 750 Newton, and by the given pulley system. Given pulley system means, look at the pulley system. Here, what is the velocity ratio of this pulley system? 2 wheels are shown. Its velocity ratio is 2. No. Number of segments of the string supporting the load is 3. This is the twist. That's why velocity ratio of this pulley system is 3. We can write here VR, which is given in the diagram, actually 3. We have two questions here. Efficiency and work output when effort is applied to 3 meter distance. Effort distance is if 3 meter, then what is efficiency and what is work output? Work output. Now how to calculate this? First, efficiency we can calculate easily. We have eta is equal to MA upon VR into 100%, and this is equal to MA is load by effort. Load is 750 Newton and effort is how much? Effort is 300 Newton, and divided by velocity ratio is 3 into 100%. And if it is so, then Look at this 2 0 and this 2 cancel each other. 3 3s are 9, 750 Newton divided by 3 into 3. 3 2s are 6, 3 5s are 15, 250. If we divide this 250 with 3, then we'll get what? Eta is equal to 3 8s are 24, 3 3s are 9 and 83.33%. This is the efficiency. Now there is another part also. What is asked? Work output. I want to calculate work output also. Work output. Again, look at this. Work output is equal to load into load distance, and load is given here 750 Newton and load distance is given 3 meter, and if we multiply these two, then 0 remains same. 5 3s are 15, carry over 1, 7 3s are 21, carry over 1, and that's why 2250 Newton meter means joule. Now we can say that work output is 2250 joule. Okay, this is the solution of numerical problem. Now I want to just recall what we did. First, what is pulley? But before that, I told you what is simple machine also. Why simple machine magnifies the effort, and how it increases the speed of the work, how it makes work convenient, etc., etc. And then we entered into pulley and different types of pulley I told you, and I defined all the pulley, and I presented the diagram of different pulleys and the example of pulley in our daily life also. And lastly, I solved some numerical problem related to pulley system and different types of pulley. I think now you can define them, you can present this pulley if necessary at any place, and you will be able to solve the numerical problem also. Okay, this much for today. Next class we'll meet with some other type of simple machine beside pulley. Thank you.